Most of the time, the scripts you write will be single use, and you're going to know everything you need to know about when you're writing the script. But often, you're going to be writing reusable scripts that either need to collect information from the user or that perhaps you're going to populate based on information that you put into a file. So to collect information from the user, you can use the read host commandlet, and that's going to prompt them at the console. And to read information in from a CSV file, you can use the import CSV commandlet. Read host displays a prompt and always returns a string, whereas import CSV returns an array of custom objects. What's really cool about import CSV is the object property names come from the first line of the file. So you don't even have to go through any sort of effort to build up custom objects to say, this is what I'm going to use to store this file. PowerShell will do that for you. All right, so let's take a look at this in action. All right, so read host is pretty darn simple, and there's just not a lot that needs to be said about it. Let's do a little demo here. We'll create a variable called name, and we'll just ask, what is your name? So I'm going to say read host, and we'll say, what is your name? Right, and when we run this, you can see that what is your name appears at the prompt, followed by a colon. And I'll say my name is Doug. And now if we check the name variable, we can see that it contains Doug. Now import CSV is the second commandlet we want to look at, and it's really one of my favorites. I have a CSV file that I created previously. Let's find it here. It's under Users Administrator, I believe. And here it is, People CSV. We'll just open this up with Notepad. And you can see that it's got 3 columns, first name, last name, and phone, and then 3 records. All right, so let's close this and import this into an array of custom objects. All right, so let's say we'll create a new variable, we'll call it people. And this is going to be equal to import CSV, and it needs the path to where the file is. What's cool about ICE is that it also has IntelliSense for directory contents, and so there is people CSV. All right, so let me run this, and it just finishes instantly. And if we check people, see what kind of thing it is now using getType, we can see that this is an array. And if we check the first item in the array, for its type, we can see that this is a PS custom object, right? And what's custom about it is that PowerShell created properties for all of the things that we had in the first line of the CSV file. So first name is Sue, and last name is Smith, and phone is equal to the phone number. And of course, if I change the indexer on the array to 1 or 2, we would see a different record altogether. Okay, so by now you've probably seen some loops in action via some pipeline operations, but there are some actual commands that are built into PowerShell that will let us do loops that are part of the language. First one is called for each. And for each in PowerShell behaves pretty much just like it does in .NET, which is that it iterates a collection, and each time it passes through, you get the current item in the collection. It can also be used to iterate an array of numbers to simulate a traditional for loop, which PowerShell does not have, and I'll show you how to do that in just a second. And sometimes when you use for each in a pipeline operation, or actually always when you use for each in a pipeline operation, it's actually an alias for the next looping command that we're going to talk about, which is for each object. For each object also iterates a collection, but unlike for each, it has more options. So it allows a begin block, a process block, and an end block, just like a function does, so that you can set up your processing before the pipeline processing begins and then do some cleanup at the end. Now, if you do this, it needs to be on one line. Finally, there is a symbol which is the percent sign. And the percent sign aliases for each object. This is a syntax that throws a lot of people off when they're new to PowerShell because they'll often see the percent used to do a loop, and we'll take a look at that right now. Alright, so let's start off by looking at for each. What I'm going to do is I'm going to get a collection of files by using the getChildItem command. And this is going to give me the folders and files that are in C Users Administrator. So we'll say get child item, and now we're going to loop through this collection and write out the name of each file to the console. Alright, so we'll just say for each, and for each takes its things inside of a set of params. So we're going to say for each file in files, and then we will write out the file name to the console. Alright, so this is nice and simple, and if we run this, you can see that it works exactly as we would expect. So this takes a variable to populate a collection, and it involves a couple of lines of code, and we could do all of this with a pipeline operation, and we'll do that in just a second. But before we move on for each, let's take a look how we would do a traditional for next style loop that counts through some numbers. All right, so this time we're going to say for each, and we're going to say we have a number. This could be I or N or whatever you like to use in your loops, or C, and we're going to count from 1 to 100. And then we will simply write host N, just like we did with files a second ago, right? And so if I hit enter, right, you can see that it counted up from 1 to 100. We can also go backwards by going 100.1. Right? That time we counted down from 100. And very often you'll see this done using the percent instead of for each, using this kind of syntax. So we could say 100.1, which, by the way, this creates an array of 100 elements which go from 100 to 1 in order. And we could take this array and pipe it into the aliased for each object, and I could use write host, but I'm just going to leave that off and write this right out to the output. And you can see that that gives us the exact same sort of experience as we get with for each, but the syntax is a lot different. So if you're new to PowerShell and you've seen something like this, well, now you know what it does. All right, so now let's take a look at for each object. And so this time we're going to do the same thing that I did in the first demo, except for instead of populating a files variable, we're going to pipe getChildItem straight into for each object. So we'll say getChildItem, and we'll pipe this in. Now, I could use this or this because they alias this, which is for each object. I don't know why that keyboard shortcut sometimes works and sometimes doesn't for me. Alright, so if we want to begin an operation, we use the begin parameter and pass it a script block. And so this is going to take a variable called count and set it to 0. And then we'll write out to the host that we're beginning our process. And I need to separate my lines with a semicolon because this is all on one line. All right, and then for each one of the items, we'll just write out the current items name. And you can see IntelliSense is really smart here. It knows that I'm piping getChildItem into this block, and so it gives me IntelliSense for this. And then after we've written out the name, we'll take the count and increment it. And I didn't get IntelliSense here because I spelled it wrong over here. And then finally we'll do the end, and we'll just say that we found whatever number of files that we read. All right? So just to review, before I hit enter, this needs to be on one line, and we're piping getChildItem into this, and we're going to write starting, set our count to 0, write out each file name, increment the count, and then at the end we're going to say how many files we found. So let's hit enter and see how this works. Right? There's starting, there are all our files, and then there is found 13 files. The PowerShell language supports conditional operations pretty much the same way every language I've ever used does, which means that it's got an if statement, which takes an else if and an else block. So if one condition is not true, then evaluate the else ifs. There can be more than one else if, and if none of those are true, then execute else. Only one of the if statements can be true and also execute. Then there's another statement called switch, and switch takes an expression and then it compares it to a number of other expressions and executes the ones that are true, and it also has a default block that's going to execute if none of the expressions are true. And the biggest difference between switch and if else is that it's possible for more than one of the switch conditions to be true and therefore execute. Okay, so let's take a look at this in action. If you've done any programming in any language, this is going to make perfect sense to you. Alright, so let's create a little function, and what this is going to do is write out odd or even depending on the number that we pass into it. So we'll call this function odd or even. And since we're in PowerShell, I guess I should camel case this. Alright, and so odd or even is going to take in a number, n, and what it's going to do is say if n modulus divide, so this gives us the remainder, modulus divide by 2 is equal, EQ is a comparison operator, to 0. If it's even, it's going to be equal to 0. Then we're just going to write out to the host that this is even. Right, and then of course the else block is going to say odd. And to test this function out, we'll just use a little loop in a pipeline. So we'll say from 1 to 100, pipe this into a loop, and this is going to be odd or even with the current item. And fix my script blocker. Alright, so when I run this, we should see odd, even, odd, even, odd, even from 1 to 100. Alright, so let's run this, and there you go. Pretty straightforward. Alright, now let's take a look at switch. And so we'll name this function switch demo. And this is also going to take in n as an argument. And this time we're going to just say switch and evaluate n. And we'll test n to see, let's see, is n equal to 1? Well, if it is, we'll just say n is 1. And if it's 2, we'll say n is 2. And if it is 5 minus 4, we'll say n is still 1. And then the default is going to be n is something else. All right. Clean up these extra line feeds that I've got here, and then we'll run our little loop again. So except this time we'll go 1 to 10. This is going to be switch demo, current item. All right, so let's run this. And we can see n is 1 and n is still 1. And so this proves that on the first pass of the loop, this was true and this was true. And so PowerShell executed both of these blocks. The second one, n was equal to 2. And then for the rest of them, we hit default and n was something else. Now, in the last demo, when I wrote that if statement, I used an operator which was -eq, which I said stands for equal. This is syntactically probably one of the biggest differences between PowerShell and .NET, upon which PowerShell is based. Both C# and F# and VB.NET all use mathematical symbols in order to express operators. And there are a whole bunch of different operators in PowerShell. I'm going to cover a bunch of them right now. Most of them are self-explanatory, but a few of them are a little bit confusing, and so we'll take a look at those as part of a demonstration. All right, so first we have the one you saw, which is equal, and it's got a corresponding one, which is, of course, not equal. Then we've got greater than or equal to, less than or equal to. And these are all pretty straightforward, but it starts getting confusing when we start talking about string and array comparison operators. So the next one is like. And like is used to compare two strings to see if they are like each other. And like is typically used with wildcard characters in order to specify what the match is. Of course, there is an inverse of this, which is not like. Confusingly, there is also one called match. And match does a very similar thing to like, except match is much more permissive. So like requires you to give a set of wildcards to satisfy the condition, where match will work if the string you're comparing is inside of the other one. So match is kind of like string contains, if you're familiar with .NET. And then the inverse of that is not match. The next one we have is actually contains, and contains is not a string comparison operator. Contains is used to check to see if a collection or an array contains something. And the inverse of that is not contains. Syntactically, contains has one that it basically works the same way, which is called in. The way you can understand the difference between contains and in is that contains starts with some collection, and so we'd say the collection contains some item. Whereas in is the opposite. It starts with the item and says in the collection. And of course we have not in, which is the opposite. And then finally we have one which is shown as an operator, but really isn't a comparison operator, and that is replace. And replace is used to replace the contents of one string or a portion of the contents of a string with another string. All right, so just to make it much easier for you to understand the difference between like and match and contains and in, let's jump over and actually see how these behave inside PowerShell proper. All right, so let's start off with some basic ones. All right, we can say that let's try that again, 3 EQ3, and run that, and it's true. And if we say 2 not equal to 3, that's also true. Where this gets interesting is when we start talking about strings, because by default, string comparisons are not case sensitive. So if we say ABC is equal to lower a, big B, lower c, why, that's true. And so for string comparison operators, there's usually, or really always, another form which starts with a C, and C says compare the cases. And so this one is false. Now I said I was going to show you the difference between match and like. Let's take this example again, and I'm going to say ABC, does it match B? Right? And the answer is true, because B is in ABC. If I said, is ABC like B? The answer is false. So what I need to do is use wildcard operator to make like more explicit. So ABC is like splat B splat. Now, if you're still confused about the difference between like and match, then I encourage you to just jump into PowerShell and do some experimentation. It'll become clear to you quickly enough. What I find is that I usually prefer the better rigor that like gives me, but you may feel a little different about it. So now let's look at the difference between contains and in. All right, so I'm going to make an array. We'll make an array that's got numbers in it. So these are going to be 2, 4, and 7 in our array. And let's see, does our array contain 7? And the answer is yes, it does. Now, this is basically the opposite way of writing the same thing, which would be to say 7 is in 2, 4, and 7. And that is true. But if we were to take this and flip it around, the answer is false, because 7 does not contain an array of 2, 4, and 7. Right? 7 is in 2, 4, and 7. Right? And so we could do similar things with ranges. We could say 1 to 10, an array of 10 numbers contains 5. And the answer is going to be true. But if we said is it 11, the answer is going to be false. And then of course we could also say is 7 in 1 to 10, and the answer is true. One of the goals of the PowerShell team was to make PowerShell easy for administrators, people who are not professional developers. And a lot of the things that you see in PowerShell 3.0 go to that. The ability for PowerShell ICE to give good IntelliSense is one of those things, but the biggest thing is got to be the help system. The ability to type get help followed by whatever it is that you want help on, and get a nice console window full of detailed instructions. Well, you can do the same thing for your scripts and functions and commandlets. Now, PowerShell has got an incredibly rich system for this, and so I'm just really scratching the surface. The first thing I want to tell you is that comments, not necessarily comment-based help, but comments start with a hash symbol. But you follow the basic pattern shown here in order to support get help, which is that you have a less than pound greater than to delimit the help content, and then you get dot help keyword, and then the help content goes inside of that. Now, like I said, this is incredibly rich, and so I would refer you to the about comment-based help topic, which will show you all of the possible keywords that you can use, things like synopsis and examples and just a whole bunch of them. And it also has good examples. What we're going to do now is just do a really simple one and create a synopsis for a basic function. And I think this is a good practice anytime you're going to write something that you may need to use a year later or that you're going to give to somebody else. One of the nice things about the comment-based help system is that you can put your comments in a few different places depending on your own personal style. In the case of functions, you can put the help right before the function declaration as long as there's not a white space In other words, it needs to be on the line right before the function declaration. You can put it right at the top of the function body or right at the bottom of the function body. And so what I'm going to do is I'm going to actually put my little help topic right at the top. Okay, and so we're going to start off with less than pound, and this is going to end with pound greater than, so I like to mark my delimiters right off the bat. And I'm not going to write a really deep involved help topic. I'm just going to create a synopsis, which is always at least the minimum that you should provide. So this is synopsis, one of many possible keywords that we could use. And the synopsis for this is going to be writes hello world to the host. And I said that like it's an exclamation, so I'm going to put an exclamation point on the end of it. All right, and then we just say function. Obeying our verb noun syntax. This is write hello world. And we'll just say write host. Hello world. All right, so let's save this and run it so that this gets loaded up into our current session. And now I can say get help write hello world. We can see that it says, there you go, writes hello world to the host. The keywords, at least the basic ones, are shown here. Name, we don't have to provide that because it's part of the function. There's the synopsis, which you saw. Syntax is automatically filled in for us as well. But description is where we would put a longer topic, related links, remarks. You get the idea. Once again, I encourage you to always do this for great in-depth documentation about all of the options that you have for this commenting system. Use get help about comment-based help. Let's wrap up our discussion about basic scripting by talking about error handling. Now, error handling in PowerShell is something that a lot of people neglect because errors don't stop a script from running. If you're writing a compiled C# or even if it's JavaScript and you've got an error in a particular function, then everything stops. Everything comes to a grinding halt with an error message. But PowerShell will just throw an error and put it into the object pipeline and then just keep right on going. So if you want to know if something went wrong, you must actually check. And you can do this by using some of the automatic variables that PowerShell provides for you. The two main ones are error, which is the error buffer. An error is an array that contains all of the errors that have happened in a session up to a limit. The default is 250, but you can change it by setting the max error. The thing about error is the most recent error is always going to be the 0th element in the array. And then the next one is $?, and this tells us whether or not the last operation was successful or not. So a good pattern for error handling would be to clear the error buffer and then go about your business checking for the last operation success at each step of the way and then responding appropriately. All right, so that's really, really simple. There's no try, catch, finally, or any of that stuff that you might be used to from .NET or try, catch that you're used to from JavaScript. We just have a few automatic variables and the rest is up to us. All right, so let's jump back over to PowerShell one last time and add a little bit of error handling to write hello world function that I just wrote a second ago. All right, so we're going to make our write hello world function a little bit more robust and also a little bit less robust because we're going to deliberately cause an error. Now, when I'm writing a function that's going to do something critical, I like to clear the error buffer right up front. Now, this is my personal preference. There's room for debate on this, but I don't like the fact that if I check to see if error has anything in it, that I might actually be seeing an error from some operation which is long since passed and I can no longer react to. All right, so I always go error clear right up front if I'm interested in doing some error handling. All right, now there's not much that can go wrong with hello world, but let's see, just by checking the $? variable, that's going to be true if it worked and false if it didn't work. And so now let's try to do something that definitely won't work. I'm going to try to set true equal to false. Both of these are read-only constants, and so this is definitely right out and not allowed. And then finally, we will check to see if that operation succeeded. And we'll go ahead and save this and run it so the current version gets loaded up. And now we'll do a write. Whoops, I didn't actually ever run it before. Let's do a write hello world. And you see that it wrote hello world, and that was successful because it returned true. And then it said this, no, we can't do this, and so we got an error message, and if we check, we can see that that actually failed. Now at this point, if we check the error collection and see how big it is, we can see that we have exactly one error message inside of it. And if we look at the 0th element, then there's our cannot overwrite variable because true is read-only. All right, so not much to error handling, but very important. Don't just assume, especially when you're working with files and folders and things that you expect to be there but might not be, that everything is going to be great. And actually give some thought to what could go wrong and then code appropriately.